Here we go. Man, these are a lot of fun. So again, we're just moving through some practice problems. This one is very similar to the last problem. And so it won't be too much of a surprise. It's just extra practice. Now, when we get to number 6 and number 7, they're a little different, particularly number 6. But follow along or try it on your own. Either way, here we go. We are going to factor. This is x minus 2. I had a hard time writing it. X plus 1. The denominator is x minus 4 and x plus 1. I see it. You see it. I scream. You scream. We all scream for frozen yogurt. X minus 2 over x minus 4 is the function that I'm really dealing with, but I took out a factor. And because I took out a factor, there is a hole in my graph. And a snake in my boot. Sorry, couldn't resist. You have to quote Woody from Toy Story any chance you get. So there's a hole in the graph at x plus 1 equals 0. So in other words, x plus 1 equals 0. So x equals negative 1. I don't just want that. I really want to know the coordinate. My final answer is going to tell me there's a hole at negative 1 comma something. I need to know what that something is. So I'm going to plug a negative 1 here and here. So y equals negative 1 minus 2 over negative 1 minus 4. And that gives me negative 3 over negative 5. That is 3/5, because we can make them both negative, positive. Negative over negative is positive. There's a hole in the graph at negative 1, comma, positive 3/5, so somewhere around in here. It doesn't have to be perfect, but a little more than halfway between 0 and 1. All right, that was the hole. Let's do the x-intercept. That's where y equals 0, so 0 equals nope, nope, yes. 0 equals this. I don't feel like cross multiplying because you know what's about to happen. 1 times that gives me that. 0 times that gives me that. And I cross multiplied anyway. There we go. X equals 2. Fantastic. Now, there are some teachers, and they are not wrong in saying this. They would say that's not your x-intercept. That's an x value. I hear you. I agree with you. I used to require this as well. So if you want to get picky about it, you want to get technical, and it's actually a really good practice. I just haven't done it up to this point. The x-intercept is actually the coordinate 2, 0. So if you're going to plot it as a point, like I did this one, you'd say, well, that's at 2, 0. I don't generally make a huge deal out of it, but I would like for you to understand that this is actually a coordinate, not necessarily x equals 2. That sounds like an equation, right? So y-intercept is, well, y equals 0 minus 2 over 0 minus 4, and that is negative 2 over negative 4, that's a half. So you could say that y equals a half, 1/2, not 1/4, sorry. You could say that y equals a half. And that's fine. That's what we've been doing. And I would say, oh, that's a y-intercept. So I come over here and put a dot at 1/2. But if you want to get technical, and I'm starting to get technical on this one, not that anyone criticized me, but I noticed that it might look a little confusing that we have equations here and equations here, but these are coordinates and these are not, okay? So this technically is 0, 1/2. And that's why we have a coordinate there. All right, the horizontal asymptote. I did it again. Muscle memory. Horizontal asymptote is where this thing levels off. Okay, well, I'm going to graph this one, actually. And when I graph it, I'm going to graph the original problem as well, actually. And you'll see what it looks like. So here goes. Minus x minus 2. That's the numerator. Here's the denominator. Minus 3x minus 4. There we go. All right, let's take a look at this graph right here. Where does it level off? Horizontally. Let's slide that over there. Okay, well, no. Ceiling fan? No. Yes. Okay, so where is that? Where did I cross the y-axis? The y-axis got crossed at 1. There we go. So it's y equals 1. And if you wanted to, if you really want to check it, you could type that in. You could say y equals 1. And when you do that, boom, you get that horizontal line. And they never cross, because this is not one of those problems where they do. So y equals 1. And shortcut doesn't always work, but in this case it does. Shortcut is going to be ignoring these extra numbers and saying 1x over 1x is 1. Okay, it's going to get a little tricky in a minute. if we try that strategy on the next problem. Vertical asymptote is where the denominator equals 0, and we can see it on our graph. It's this one right here, and it's at 4. So you could say x minus 4 equals 0. You could say x equals 4. There we go. So let's graph a couple of these. Let's cross the y-axis at 1. You can cross the x-axis at 4. Here we go. We're going to go through that hole, but not really. And then this one's over here. What about the dots over here? Maybe you could plug in points to test it and see what works, but I'm not going to get too picky about that.